Hello guys, how's it going? Here's Mike coming back at you with yet another version of live commentary of Math 130 videos. As you know, we've had some videos that have been having some audio issues, so I am doing a live voiceover of them. In this video, we're talking about linear equations. What the heck is a linear equation? These things may be familiar to many of us. It's an equation that can be written in the form ax plus b is equal to 0, where x is our variable, a and b are real numbers, and a is not equal to 0. A can't be 0 because if it is, then our variable x is gone, and then we have something that is either very boring or something that is not a valid equation. So that's why a can't be 0. What makes this linear is that the exponent on the variable x is 1. If it was anything else, this wouldn't be a linear equation. Any value that makes the equation true, as you can see, is called a solution, and the set of all solutions to a linear equation is called a solution set. And we'll see that we could have just one value, we could have no values, or we could have an infinite number of solutions to a linear equation. So we're going to be seeing those possibilities as we go throughout this video. Once again, I'm sorry for this error in audio that we had in these videos. Thank you for pointing this out to me, those of you who caught it and sent me an email. Now I can at least get you some commentary and have this video make some sense. If we have two linear equations, they have the same solution set, then we say that the equations are equivalent. So now actually getting down to solving these linear equations, how do we solve them? We're going to simplify each side of the equation. We're going to distribute constants in, combine like terms on each side, just get things looking nicer. It may be given to you like that. It may be given to you kind of ugly looking, but just doing some simplification will definitely help. Then you're going to add or subtract terms so that all the terms containing an x are on one side of the equation, and then you're going to add or subtract terms so that all the constants, all the terms without an x, are on the other side. You're then going to combine those things. 3, you're going to divide both sides by the coefficient of x. If you haven't seen that word before, coefficient is just a fancy mathematical word for the number that you have in front of x. And then 4, just as a check, just sort of make yourself feel more confident that your answer is indeed correct. Check the answer that you get. Plug that value back into the equation you were given at the start and verify that the two sides equal each other. So here's an example of a linear equation. 4 times the quantity x plus 2 minus 3 equals 6 times the quantity x minus 1 plus 7. As you can see, the exponent on each of these the exponent on each of these x's is 1. So that's again what makes it it's what makes it a linear equation. I wrote there on the slide for some reason, not totally sure why, but I multiplied the 4 into each term in the x plus 2, and I multiplied the 6 into each term in the x minus 1. So that puts us here, 4x plus 8 minus 3, and 6x minus 6 plus 7. I can combine these constants to give me 4x plus 5 equals 6x minus 1. And now I'm going to add or subtract terms from each side. So all the x's are on one side, all the constants are on the other. And I'm going to subtract the 4x from both sides. I'm going to move that over there, and I do that by subtracting. I'm going to move the 1 over to the other side, and I do that by subtracting 1 from both sides. Or some people think of it as clearing out the 1 and clearing out the 4x. Whichever phrase you have perhaps heard it in the past, and whatever way you're more comfortable with looking at it. But in the end, we're going to get 2x is equal to 4. And then I just have to divide both sides by 2. And that gives me x is equal to a positive 2. And it's as if by magic that I knew that this was going to show up. So there's an example of solving a linear equation. This is an example where there is only one particular solution. And when we have a linear equation that only has one particular answer, only one x value, we say that this is a conditional linear equation. This thing is only true when x is equal to some particular value. Hopefully everyone's been having not much trouble with the course so far. If you do have questions, once again, guys, reach out to me, ask me questions, send me emails, stop into office hours. There's a lot of time there which I have open for you guys there to ask questions that you may have. So here we're doing another linear equation. 4 times 5x plus 3 equals 2 times 10x plus 6. So we're going to solve this guy and see what we get. Again, distribute constants in. So 4 times 5x is 20x, 4 times 3 is 12, 2 times 10x is 20x, 2 times 6 is 12. Okay, now this is interesting. Note that we get exactly the same thing here. We have exactly the same quantity on each side, regardless of what x value I plug in. Well, we said earlier on, a linear equation could have one solution, it could have no solutions, or it could have a non-finite number of solutions. So I want you to guess as to which one this is. If we can pick any x value whatsoever and have the two things be equal. Hopefully you guessed correctly. We have a non-finite number of answers here. Our solution set is all real numbers. And when you have something like this, where it doesn't matter what x value you plug in, you have what's known as an equivalent set of linear equations. The third type we can encounter is what's known as a contradiction. This is when there is no such possible solution to a linear equation. And here's an example of a contradictory linear equation. 5 times the quantity 2x minus 4 equals 2 times the quantity 5x plus 1. If I were to multiply these things out, I would get 10x minus 20 equals 10x plus 2. And I can then subtract 10x from each side. There you go. I just fixed my, made my correction there. So 10x minus 20 equals 10x plus 2. And if I subtract 10x from both sides, then I'm going to get minus 20 is equal to a positive 2. Now, negative 20 is never equal to a positive 2. So that's what makes this thing contradictory, or that's what lets us say that there is no solution to this linear equation, because we just can't ever get these two things to be the same. You can try to clear everything out from one side, as I did here, and you come up with 0 is equal to 22, which obviously we know is not correct. Those two numbers are clearly not equal to each other. So those are the three types of linear equations that we can have out there. Contradictory, or contradiction, where there are no solutions. Equivalent linear equations, where every real number is going to be a solution. And then conditional, where only one linear, or where one x value is going to be a solution. Now, where can we use these things in real life? What are some real life applications of linear equations? Suppose you're buying a house and you have two choices for making mortgage payments. You can either give a $10,000 down payment and make a monthly mortgage payment of $800 per month, or if you give a $40,000 down payment, your monthly mortgage payment is $500 per month. After how many months will you have paid the same amount of money under each choice, or for each choice? So what we're going to be doing here is we're going to be setting up some linear equations for each of these choices that we have. And the question wants to know, after how many months will we have paid the same? So that's sort of our cue here, that we're going to take those equations and set them equal to each other. We'll be doing that very shortly. Once more, guys, just reach out to me if you have any questions. Very important to know how to do this kind of stuff. So now, setting up our equations here, what's being multiplied by the x, or whatever letter we're going to use here, and what's being added on after? The $10,000 down payment is the one-time payment that you make. We just make that once and that's it. The $800 is what we pay every month. So what we're going to be paying is the $10,000 that we started with, plus $800 per month times however many months we have. So here, time t is measured in months. So we say that how much we're paying after t months under choice 1 is 10,000 plus 800t. You may be wondering, wait, aren't we using x's? T is the second most common letter that we use to stand for the independent variable. Under choice 2, we make a one-time payment of $40,000, and then every month we pay $500. So what we're paying after t months under choice 2 is the one-time payment of $40,000 plus $500 per month times however many months have passed by. So that's why it's 40,000 plus 500t. We wanted to know when what we would be paying under these choices would be the same. So we're going to take these two linear equations and we're going to set them equal to each other. So 10,000 plus 800t equals 40,000 plus 500t. Again, get all the terms with our variable, t in this case, onto one side, all the terms without our variable onto the other. So I'm going to subtract 500t from both sides. That's going to leave me just t's on the left. And then I'm going to subtract 10,000 from both sides, and that's going to leave a constant on the right-hand side. And when you do that, you come up with 300t is equal to 30,000. Last step, divide both sides by that 300. And if you plug it into your calculator, if you're not sure, 30,000 divided by 300 is going to give us 100 months. So given the information in this problem, after 100 months, it doesn't matter which choice you made, you will have paid off, or you will have paid out the same sum of money to pay off this house. 100 months is 8 1/3 years. And this is a fairly realistic type of question here. Yes, when you purchase a home, there's taxes and other interest things. So we are sort of, in essence, removing interest on the loan and things like that. But still, overall, this is a fairly realistic type of real-life application of linear equations there. Now, what if we are seeing rational equations? What if we're seeing things like something over an x, or something involving an x over some number, or something like that? Well, we have a very similar process. There's just some extra stuff that we have to do first. First thing we have to do is we have to find a common multiple between the denominators of each fraction in the equation. A common multiple is simply just the product of the bottoms of each of those fractions. Then, once you've found that common multiple, you're going to multiply on the top and bottom of each fraction by this common multiple. Then you're going to cancel and simplify. The reason we multiply on the top and bottom is so that we're multiplying everything by a 1. We're not changing the fundamental quantity that we have. We are just changing how it looks. When you do this, you're going to get a resulting linear equation. And you're going to solve that resulting linear equation as normal. And I just realized in step 2, you're not multiplying on the top and bottom. You are just multiplying on the top. That is my bad. So here, kind of basic equation here. 4 equals 2 plus 3 over x minus 4. So I need to find a common multiple between the bottoms of each of these fractions. Well, there's only one fraction here. There's just x minus 4. So what I'm going to do is I'm going to multiply each side of this equation here. Again, just on the top, not on the top and bottom. Once again, that's my bad. I apologize. I'm going to multiply on the top of each side, or just multiply each side, by the quantity x minus 4. Technically, the other two terms there Technically, they are fractions, but the bottom is 1, and that's not going to change anything. So just multiply on both sides by x minus 4. And when we do that, we're going to get this step right here. The left-hand side, 4 times x minus 4, that's nothing crazy. The right-hand side, we're going to have 2 times x minus 4, which we can do. And then we're going to have x minus 4 times 3 over x minus 4. And in that case, the x minus 4s are just going to cancel out. So what this turns into is 4 times x minus 4 equals 2 times x minus 4 plus 3. This is now down to one of those nice, simple linear equations that we saw earlier on in this video. We can easily figure this guy out on our own. Nothing too complicated happening here. If I multiply the 4 in on the left-hand side, I get 4x minus 16. Multiply the 2 in to each term on the right, and then combine, you get 2x minus 5. I subtracted 2x from both sides here, and then I added 16 onto both sides. So again, all the x's are on one side, all the constants are on the other. And when you do that, you will get 2x is equal to 11. And then lastly, just divide both sides by 2, and we come up with our final solution. X is equal to 11 halves. So that's kind of an interesting little problem there. Again, the only new thing that we're doing here is we are really just multiplying both sides of our equation by that common multiple. So guys, this concludes our voiceover of our video on linear equations. Again, any questions, reach out to me. Thank you very much, and take it easy.